Hello there, Mr. Sutton here with the AB Calculus 3-9 Extra Practice Number 2 solutions on tangent lines and higher order derivatives. On this problem, we have this function f here, and we want the equation of the line tangent to this function at x equals -1. Well, for a tangent line, we need an x and a y value and a slope. For the y value, we can just plug -1 into the original function. So f of -1, which is all of this stuff with -1 plugged in. Going from left to right here, this is going to be -4 plus 5 is 1 plus another 3 is 4 for that grand total. And we also need the slope. So for this, I need the derivative of the function f prime, which is going to be, using our power rule, 12x squared minus 5, and then that 3 just gets zeroed out. So plugging -1 in here to get the slope at x equals -1. This is going to be 12 times -1 squared, which is just 12, minus 5 gives us 7. I'm going to put all this together now in point slope, and I'll probably have to change my form because these answers are not in that form. But let's just start there. So I have y minus the y value 4 equals my slope that I just found of 7 times x minus the x value they gave me of -1, so actually x plus 1 we can write. And to put this back in this form now, let me distribute this out and add the 4 over here. So I've got a 7x after I distribute that. I'm also going to have a plus 7, but if I add this 4 over here, that's going to be plus 11. So that's going to be choice C. On this problem, we want the equation of the tangent line to this curve at the point 1, -3. So for that, I need an x and a y value and a slope. They actually gave me the x and the y value right off the bat, which was nice. So we just need to know the slope of this, I don't really know if I want to call it a function, this equation at this point here. So we're going to need the derivative, and we're going to have to use implicit differentiation because it's kind of hard to isolate y in this one. So going left to right, we have derivative of x squared, which is 2x. And now we need a product rule to handle this -3xy. So setting up my box and ribbon here, I have factors of -3x and y. And the derivatives of those are -3, and using implicit differentiation, dy over dx. Putting the ribbon on these to put them back in here, I've got minus 3y. And then coming back the other way here, this is going to be -3x times dy over dx. And all that's going to equal the derivative of 10, which is 0. Isolating dy over dx now, I can subtract the 2x, add the 3y, keep the -3x dx over dy here. So this is staying on the left side, and we've got -2x plus 3y on the other side. And now let me just divide everything by -3x to really get dy over dx by itself. So there's our derivative. Now we actually need the slope of this function at 1, -3. We need a number. So we're going to plug this point now, 1, -3, into this dy over dx. So doing that, I've got -2 times my x value of 1 plus 3 times the y value -3, all over -3 times the x value 1. So that's going to be, let's see here, this is -2 minus 9 upstairs, so -11 up there. And we have a -3 downstairs, so 11 over 3 if we cancel out those negatives. And plugging this into point slope now, we've got y minus the y value -3, so y plus 3, equals the slope we just found of 11 over 3 times x minus my x value of 1. And does that match any of the answer choices? Well, these are all y plus 3s and x minus 1s. So really it's just down to this slope of 11 over 3, which is choice E. For this problem, they're telling us x plus 7y equals 29 is the equation of the line normal to the graph of f at the point 1, 4. Based off of this, we want to know f prime of 1. The key here is recognizing that a normal line and a tangent line have opposite reciprocal slopes. They're perpendicular. So if I can figure out the slope of the normal line at this point, then that'll tell me the slope of the tangent line, which is basically what f prime of 1 is going to give us. So let me rewrite this equation in mx plus b form to make the slope easier to pick out. So I can subtract x from both sides, and then divide by 7, so that's going to be negative 1/7 x plus 29 over 7. And now just taking the derivative, or just recognizing that this is the slope here, we have a normal slope of negative 1 over 7. So again, this is perpendicular to the slope that we actually want at 1, 4. The slope we want at 1, 4 is the opposite reciprocal of this, which is positive 7. So that's the value of f prime of 1, which is going to give us choice A. For this problem, we have this equation x squared plus y squared equals 25, which we know is a circle. We want the second derivative of this thing at the point 4, 3. All right, well, I'm going to need to take the second derivative and plug in this point, but first I need to take the first derivative, and for that I'm going to use implicit differentiation because this y is kind of annoying to get by itself. So we've got 2x plus, this will be 2y dy over dx because I'm using impdiff, and that equals the derivative of 25, which is 0. Isolating dy over dx, we can subtract 2x from both sides, and then divide by 2y, and I'm going to cancel out those 2's, so we can say dy over dx is just going to be negative x over y. All right, so that's our first derivative. To get the second derivative, I'm going to use the quotient rule. So y, or u prime v minus uv prime over v squared. Let me get the box and ribbon out for this. So I'll use negative x as my numerator term, and then that means I have a positive y for the denominator. So derivatives are going to be negative 1 and dy over dx. So I actually want to just plug 4, 3 into this thing now, and I'm going to do that inside the box. But before I do that, you see here we have a dy over dx, so I need to know the value of the first derivative at the point 4, 3. So let me go ahead and evaluate that back up here. So plugging 4, 3 into this derivative, and this is pretty straightforward. This is just going to be negative 4 over 3. No bells and whistles, no strings attached on this one. So coming back here now, if we have an x value of 4, y value of 3, dy over dx of negative 4/3, here's what we get. So we have negative 4 for the x there. Y is 3, we said, so we have a 3 in this box. Negative 1 is just a constant. And we just said that dy over dx at this point is negative 4/3. So using the ribbon to plug all that back in, I've got negative 1 times 3. So now I'm doing the second derivative evaluated at this point. So negative 1 times 3 minus negative 4 minus 4/3. So 3 minuses is just going to give us a minus whatever this multiplies out to. And down here we have 3 squared. That's the v squared right here. All right, let's clean this up a little bit. So let's see here. We've got 16/3 that we're subtracting from negative 3. Well, negative 3 is really negative 9/3. So negative 9/3 minus 16/3 is negative 25/3. And we still have a 9 downstairs. Multiplying by the reciprocal of 9, which is 1/9, this ends up being negative 25 over 27. And we didn't have to simplify this. Well, actually we did because this is multiple choice. So that matches the answer choice A. For this problem, we have a function defined on the interval from 0 to 8, and the graph of its derivative is actually what they're showing us up here. They also told us the point 3,5 is on the graph, and they want the equation of the tangent line of f at 3, 5. So remember, for a tangent line, you need an x and a y value, which they provided, and you also need the slope at that x and y value. So for that, we need f prime of 3, f prime of our x value here. And for that, we can just look it up in the graph. Looking at the graph here at 3, we have an output value of 2, it looks like. So our derivative is 2 there. Plugging this into point slope now, we have y minus the y value 5, equaling our slope of 2 that we just found from the graph, times x minus our x value of 3. And that matches answer choice. Is that going to be C? Yep, looks like C. For this problem, we have the slope of the tangent line for this curve at 2, -1, or rather we're looking for that slope. So for that, we need the derivative of this thing, and then we need to plug 2, -1 into whatever that is. I'm going to use impdiff because I don't really see an easy way to isolate y. So we've got 2y for that first derivative there, times our tail of dy over dx, plus now I need a chain rule and a product rule inside of it. So I've got something cubed. Derivative of that is going to be 3 times the something squared. But now I need the derivative of the something, the xy plus 1. So for that, let me use the product rule. And this plus 1 is just going to be 0 when I take that derivative. So it's really just the xy that I have to differentiate. So I've got x and I've got y, and I've got their derivatives, which are 1 and dy over dx. Using the ribbon to multiply that out, and remember, this is going to end up inside of parentheses now that's getting multiplied by this. We've got y, or 1y, plus x dy over dx, close the parentheses, and all that's left is the other side of the equation. Derivative of 0 is also 0. All right, to isolate dy over dx, this is going to be a little bit painful. The only way to really quickly do this is to distribute this 3 parentheses xy plus 1 squared to both terms here, and then we can get at this dy dx inside here. So this is going to be, let's see, 2y dy over dx, that was already there, and then we've got 3y xy plus 1 squared plus 3x xy plus 1 xy plus 1 squared times dy over dx, so all that equals 0. Moving things around now, the 2y dy over dx can stay on the left, as can this term with the dy over dx over here. This term with the 3y xy plus 1 squared, we're going to have to subtract that over to the other side. Now that I've done this, I can factor out a dy over dx on the left, leaving me with 2y plus 3x parentheses xy plus 1 squared inside, so all of that. And let me just divide by that stuff now, put it under what's already on the right side. So splat, it's all there. At this point, we haven't done enough work. We still need to plug in 2 comma negative 1. So let's go ahead and do that. So in the numerator, I've got negative 3 times the y value, negative 1. And I've got in parentheses the x value 2 times the y value, negative 1, plus 1 squared. And then downstairs I have 2 times my y value of negative 1, plus 3 times the x value 2. And then parentheses, basically the same parentheses up here, 2 times negative 1 plus 1 squared. All right, time for some simplifying because we have to match one of the answer choices. Otherwise, I would just leave this the way it is. So on the outside here, we've got a positive 3. On the inside, this is negative 2 plus 1, which is negative 1. Squaring that gives me a positive 1. So when the dust settles, we just have 3 times 1, or 3, in the numerator. Downstairs, I've got a negative 2, and I've got a 3 times 2 is 6, times, we saw this squared parentheses was really just 1 when we did it up here. So negative 2 plus 6 is 4, and 3/4 is answer choice D. For this problem, we have the function y equals sine of x, and they're saying y with this little n up here means the nth derivative of y with respect to x, which we kind of already knew, but it's nice for them to remind us of that. We want the smallest positive integer n for which the nth derivative equals the original function. So basically, we want to keep taking the derivative of sine until we get sine as the derivative of something. So let's start with the first derivative of sine, which is cosine. And now the derivative of that, y double prime, is going to be negative sine of x, which is close, but not quite what we need. We need to match the original function exactly. So our third derivative then of negative sine of x is going to be negative cosine of x. Taking the fourth derivative, that's going to be negative sine of x, which is positive sine of x. And hey, wait, that's exactly what we started with. So that means that the smallest integer where we get what we started with is 4, the fourth derivative, so choice B. For this problem, we have this f of x function, and we want the equation of the tangent line for this function at x equals 1. So for tangent lines, we need an x value, a y value, and a slope. We only have the x value. Let's get the y value next. So that means I'm just going to have to plug 1 into the f function right here. So that's going to be 2 times 1 minus 1 to the 5th, and 1 plus 1. Well, this is really just 1 to the 5th, which is 1. 1 plus 1 is 2. 1 times 2 is 2, so that wasn't so bad. Now we need the derivative at x equals 1 in order to find the slope of our tangent line. So for this, I'm going to use the product rule. It's probably the easiest way to do this. So u prime v plus uv prime. Let me use the box and ribbon to organize things. So I've got 2x minus 5 to the 5th power and x plus 1. Derivatives of these, well, this first one needs the chain rule. I've got 5 times something to the 4th. Now I have to multiply by the derivative of something, which is 2, so 5 times 2 is 10 out there. And then derivative of x plus 1, which I didn't really need in parentheses here, but whatever. That's going to be 1. So now using the ribbon to put it all back together, well, actually, I just need the derivative of this thing at 1. So let me just plug 1 in directly inside the box here. So 2 times 1 minus 1, that's going to be just 1. Because if I raise that to the 5th, that's still 1. And then over here I've got 1 plus 1, which is 2. I feel like we've done this before. And because we have up here, actually. Down here now we've got 2 minus 1, which is 1 to the 4th is 1 times 10 is 10. And 1 is playing itself in this motion picture. Using the ribbon to put it all back together, we have 10 times 2 plus 1 times 1. That is going to be 20 plus 1, so 21. Winner, winner, chicken dinner. And then we've got to put this back inside point slope to get an equation. So I have y minus the y value that we found up here of 2, equaling our slope of 21 times x minus the x value they gave us that was 1. Does not match an answer choice. So let's distribute this out and put it in mx plus b form. So I know I have a 21x over here. I have a negative 21 also, but when I add this 2 over here, that's going to be a negative 19. So that's going to be choice B.